Okay, where did I? Hmm. Sorry, I'm going to have to ask one of you for a favor. Do any of you have a recorder with you, like an electronic recorder? Could someone record the lecture and then send me the link after to post for the class? Thank you. Apologies, I think I've left it in the office for some reason. Okay, so let's get going with today's lecture, and let's talk a little bit about what you need to know and what you start to have to study for your midterm, and to make sure that everything is on track. We're going to be spending today and parts of next week looking at some of the issues associated with obesity, because it's a big problem in human biology. So some of us are actually really interested in this because we're looking at the genetic effects. And we're going to take a very quick look at that, and we're going to come back to visit some of the potential genetic effects, why we actually can become obese. We're going to look at how we measure obesity again, slightly differently, as well as how we go about measuring fat levels and why those are important. They're not the same thing. And then we'll get into what metabolic syndrome is, and then we'll look at some of the molecular consequences of what metabolic syndrome is as well. And then we'll start to look very briefly at the end today, some of the models of obesity. I would like you, if you can today, to start thinking, because I'll spend the last 5 minutes or so going over that 3x3 model. I want you to put a little bit of time aside every single day and at the end of the week, going back and reviewing what you've learned here today. So whatever is new or interesting for you, whatever is completely confusing for you, and 3 slides that you think are going to be on the midterm, and then we'll take it up at the end to make sure that we're all on the same page. So I kind of left with this slide here, that right now, all of us, every last one of you, right now you're at the prime of your lives. You're in the peak mental, well, I don't know about mental because you're here at U of T anyway, so by definition it means that you like a challenge. But in addition to that, your physical peak is right now. But in the next 20 to 30 years, when you're in the workforce and when you are thinking about your job, starting a family, etc., you're going to be challenged by the same epidemic that's facing us now. I did not intend, nor did I start off trying to become overweight and or obese, but that is going to be a growing burden in the next 20 to 30 years. And as human biologists, we need to consider that. So we have to take a look. Why is this happening? Is it something in our food? Is it something in our genes? Is it a combination of those 2 different factors? And how can we try to avoid this? So I mentioned at the very end of the last lecture that behaviorally, if we can actually stop you from drinking sugary drinks, that you can actually see a reduction in the uptake of sugary drinks, and I'll come back to that in next week's class. So maybe there are changes in those behavioral paradigms. Why you eat the things that you eat are really important consequences. Because this is a growing concern over the next 20 to 30 years, and you're going to be responsible for my generation. When I'm old and when I'm retired, you're going to be looking after me. Your taxes are going to be looking after me. We have to start thinking about some of the consequences, whether they're related to Alzheimer's disease, because there is a strong indication that if you are overweight or obese right now in your 30s and 40s, that you will develop Alzheimer's at an earlier age because of some of the factors that are involved. You are also going to be at an increased risk for developing cancer versus someone of the same age and potentially even the same genetic background because you're obese. So it is a growing health concern. One of the biggest things that happens almost immediately, though, is you enter into what is known as metabolic syndrome. And metabolic syndrome is another issue, and I touched on this very briefly. Some people call this type 3 diabetes or pre-diabetes. And it's useful to go back and start thinking about what is diabetes. Why do we say that this is diabetic-like? And why are there issues with having unregulated glucose levels running throughout your blood? So If we go back to a cell, whether it is a hepatocyte, a liver cell, or a muscle cell, or other cell types, but I'll concentrate on the hepatocyte or the liver cell and muscle cell. On the cell surface of these different types of cells, we have this insulin receptor in gray. And normally, your pancreas, the beta cells of your pancreas, do a fantastic job of secreting insulin at the appropriate time. And when insulin is secreted and it runs through the circulation in the blood vessels and it encounters a receptor, it causes a couple of things to occur. And whether or not you can see this or you've learned it in another class, one of the things that happens is that this receptor dimerizes. So it's one unit, and you actually are seeing two units coming together, and it dimerizes. That dimerization, by the nature of how it works, it causes what is known as autophosphorylation. For all of you, what does autophosphorylation actually mean? Do you have any sense as to what autophosphorylation means? If you've heard it in other lectures or you've heard it in your bio class or genetics class, what is autophosphorylation of a receptor? So your alanine residues get phosphorylated in the cell? No? What happens? Any ideas? Yes, at the back. Okay, in this particular case, and you're spot on, let me just repeat what your colleague said. This insulin receptor is a tyrosine tyrosine kinase containing receptor. The tyrosine residues are phosphorylated. So we get tyrosine phosphorylation intracellularly. What other residues, by the way, can get phosphorylated from your Biochem 210 class? So tyrosine is one. There are two others that are commonly phosphorylated. What are those? So serine is another one, and what's the other one? Not histidine. So you can also phosphorylate a threonine in very similar ways. So when insulin binds, it causes receptor dimerization. That dimerization causes this autophosphorylation event, which is what you see here. This little dot says that this receptor is now phosphorylated. It will recruit other intracellular proteins that normally don't go to the insulin receptor, like the insulin receptor substrate, or IRS1. And this in turn will cause the activation of different types of enzymes like PI3 kinase, or PI3K here, which will then take different parts of the lipid in the membrane and then convert them into a signaling molecule like PIP3. All of this because insulin has bound and caused this type of reaction. And in turn, PIP3 will then activate other kinases like PDK1, and in turn, PDK1 will activate a very key enzyme known as AKT. And AKT, once it is activated in turn by PDK1, will then act to cause the translocation or the movement from the intracellular region up to the cell surface of the glucose-4 transporter. And the GLUT4, the glucose-4 transporter, is what allows that cell, in response to insulin, to take up glucose. Your cells will not take up glucose if GLUT4 is not activated, if it's not there at the cell surface. So we need insulin, and we need the receptor to be responsive to insulin. And we know that this can go awry in metabolic syndrome. We know that in type 1 diabetes, there is no insulin to be released by the beta cells, and that in type 2 diabetes, what happens is the receptor itself stops acting. It doesn't recognize that insulin is binding, and this whole cascade doesn't go into effect. But what happens in metabolic syndrome? And that's what I'm going to be talking to you about over the next week or so. In metabolic syndrome, it's useful to go back and take a look at what are the potential causes. Before I go there, do you have any questions about the signaling cascade or anything else? And I'll come back to it. And again, you should be flagging any slides that you feel will be important for you to study for the midterm, and then we'll see how we do as a class. So one question has always been, is metabolic syndrome, because I told you that it's a growing concern, and certainly in your generation, when you're out working, you're going to encounter this as a growing epidemic. So I showed you that the rates of obesity were increasing. Is this really a modern disease? And there's some evidence to suggest that our diets do. So I told you at the outset, is it genetic or is it because of our diet? So we know, for example, that before modern agriculture, before we had a surplus of food available for us, the Paleolithic diet was very different than the diet that we have now. So it had a lot of calories associated with it, so does ours, but the lifestyle was much different. They had higher activities. The types of caloric intake were also different. The micronutrients were relatively high. Um, Coming from a variety of sources like fruits, roots, and nuts, and ours are very, very low. What did you eat for breakfast this morning? Hopefully you weren't standing in line at Tim Hortons waiting for your sausage muffin combo, right? And our sources of micronutrients are very, very different. And again, if you go through the list, you'll see that overall there aren't very big differences, but there are some subtle differences on how we get our calories, etc. So again, some of you, and just out of curiosity, how many of you actually read the label of the food that you eat? And be honest. Wow, a lot of you. Okay, great. Of course, our course is about gluttony and eating. Um, so would anyone care to engage in some snacking in class? Okay, come on up. I throw it back there, but I have a really lousy arm. Um, so if you had a choice, would you take this dark mocha almond or some of the other things in here, or would you take the Nutri-Grain? The chocolate one. Okay. I totally understand that, by the way. And please feel free to help yourselves. I really hate it when students come to class and they're hungry. You just have about half an hour to go before lunch. And again, the whole point of this is you can come up now. You don't have to wait. This isn't that important a slide. You don't have to actually memorize this slide in any way. You don't have to know any of the numbers in any way. It's just to show you a couple of things. Yes, it's important for our genetic background. And yes, it's important to read what you're actually eating. But the thing is, even if you know what you're eating and you think it's healthy, so that nice Nutri-Grain bar that looks like it's healthy because it's made from whole wheat fiber, actually has more sugar in it than something that you would not expect to have that much sugar. Just help yourself. Take a bunch back up there. I think your friends are shy. They look a little hungry, to be quite honest. Yeah, see, there you go. Yep. And there are always those apple turnovers and all that. I basically took those from home because I don't want my kid eating those. Apologies. Yeah. So again, we have all these hidden calories, some of which you are aware of, things like cans of Pepsi, etc. But there are lots of other things, like soups contain a lot more sugar than you would normally think. So every day, probably, you are engaging in a type of caloric intake that is unhealthy, which far exceeds the amount of sugar intake that you should normally have. Even if you're conscious and you're trying to avoid types of foods that you think are bad for you. So some of the benefits of that Paleolithic diet, the ones that we are aware of, it will lead to lower body fat overall, lower blood pressure, you'll likely be more aerobically fit, and these hunter and gatherer individuals that were using the Paleolithic diet, in terms of their obesity as well as their diabetes, as far as we can tell from the anthropological record, we know that they probably had, in terms of their food, more fiber, less calories, even though it looked about the same, and they use much more energy than we do now. Like, think about this, right? Some of you will have a really healthy lifestyle. Some of you will be hitting the gym after class. Some of you will be hitting the gym before class. But to be honest, most of you spend your time sitting down, and you're sitting there in Sid Smith and you're having something to drink, and you have the intention of going to work out. But after a long day of classes, what do? You go home. And then what do you do there? You study a little bit and then you go to sleep. And so it's not uncommon for you as well as for me, because I know better too, to not engage in the types of exercise that will lead to greater energy expenditure than the amount of energy, the amount of calories that we take in. So for them, the obesity and diabetes tended to be really rare. We know, however, one thing. There is also a genetic component. In times where they needed to store fat, they were able to. There is a genetic component in the adipocytes that allows the adipocytes to be able to store different types of fat, to break it down and to store it effectively. So it's useful to go in and make sure that we understand a little bit about these adipocytes. And these adipocytes that you see here, beside a capillary in red, is where we store fats. We can convert some of the unused glucose into fat, fat that we'll talk about in more detail next week. And this adipose tissue is the collection of these cells that are used to store this fat longer term. And again, the key point being that it was really there to store it for when you didn't have food around. So it wasn't always possible to gather food. Sometimes you needed to eat as much as you could to store it because you didn't know where your next meal was coming from. As soon as modern agriculture came around, you knew where your next meal was likely going to be, and so you didn't really need to worry about that. Hunter-gatherers didn't really have that option, and so these adipocytes, the genes that were involved in allowing the storage of this, was really important for them. It's technically possible that we are misusing the genes that we were supposed to use to benefit our overall survival. So under certain conditions where we have an excess of glucose and we convert those to fats like triglycerides and others, that these would actually be stored inappropriately because we're not going to be burning them off. We do not have the type of lifestyle that they have. And this was sort of the hypothesis that was advocated during the 1960s, that it's really a fault in our genes and the fault in our lifestyle by Dr. Neal, and the conversion of an active Paleolithic diet into a sedentary modern processed diet that has led to this sort of epidemic of being overweight, etc. Again, you don't have to worry about this, but just to keep in mind, like a lot of you will spend the weekend going out to eat with your friends instead of studying for HMB204, like the great students that I know you are. And if you are, just keep in mind a couple of things. When McDonald's started, McDonald's was actually a fairly good option to go out and get a really quick hamburger. And then hamburger, fries, and Coke back in the 1950s when they were starting out only had about 600 calories in total. In 2016, if you get a quarter pounder and extra-sized fries and a large Coke, because they stopped calling them supersized fries, you're entering into about 1,500 to 1,600 calories. That's a lot. That's almost your entire daily intake for you as young individuals, where you need about 2,500 calories just sitting there for that one meal. And this individual here, and because this is being broadcast on YouTube, and I'm afraid of McDonald's, was considered originally to be the most evil man in America. Why? And again, you don't need to know all the details. I'm just curious. Why would you consider this individual here evil? 1979, McDonald's. What happened? Any ideas? Wild guesses? Yes. Sorry, sweet drinks. Okay, so the combo was around even back in the 1950s. You need combos. They're good for you. Yes, at the back. Happy Meal. That's right. So he was actually thinking, how can we get young people to come in and start eating McDonald's? And he developed the Happy Meal. And the development of the Happy Meal in 1975, in many individuals' opinions, is what led to sort of the epidemic in obesity. Because you get this nice little toy, and you want the toy, and you get to eat whatever else comes with it. So again, you don't have to memorize this slide either, but we're going to actually take apart this whole process. So there are aspects of hunger. You eat when you're hungry, or you're supposed to eat when you're hungry. But the actual reality is you're going to eat whenever the circumstances allow you to eat. If you're hanging out with your friends and they're eating, you're more likely to eat. If you're sitting down, you're more likely to eat. If you are at a certain time of the day, just right after class, like around 12 o'clock, you're more likely to eat than you are at like 10 o'clock. So there are different aspects of hunger that we're going to be examining in next week's class. Things like physiological hunger, where an empty stomach, different signals coming from the stomach, different hormones are going to act on different receptors within the hypothalamus and other areas that lead you to want to eat. There are psychosocial factors which we already know can influence your desire to eat. And there are also post-ingestive influences that we won't be spending a lot of time on. But ultimately, if your stomach is not sending signals, you shouldn't eat. We can control some of that, and we think that there are some biological mechanisms that we'll study next class that allows us to control parts of this cascade, things like hunger and physiological hunger, and even the feeling of feeling full, satiation. But some of these psychosocial factors are hard. And to be honest, for me, even though I know I'm overweight and I'm bordering on being obese, it might not look like I'm obese, but we'll get to that in a moment. Even though I know better, every time I sit down and my kid starts eating her quarter pounder, guess what? I want to eat that quarter pounder too, plus a Big Mac, plus the French fries, plus the drink that comes after. And so these are some psychosocial factors that really influence us. They're hard, and I'll show you why those things are hard to overcome as a human biological factor. So if we're overeating, one of the consequences of this is really metabolic syndrome. And we call it a syndrome because not only do we get this dysregulation of glucose, because that will occur, and not only do we have problems with our insulin levels, which I'll get to in the next class, but we also have all these clusters of other things. So right now, I have metabolic syndrome. I'm not really full-blown diabetic, but I have issues with insulin levels. I have a hard time controlling my glucose levels. I also have problems with my insulin levels. There are lots of things going on beyond just having metabolic syndrome. Other things can follow along with it. I'm going to have problems with my heart. I'm going to have problems with a number of other systems. So how do we determine whether or not you have metabolic syndrome? And some of those factors were ones that we discussed in the last class. And one of the things that we looked at, just being overweight or being obese, not necessarily having metabolic syndrome, was going about doing a physical examination. And you can take two different individuals that you see here, and they can have very different body types. They could have a pear shape, or they could have an apple shape. Remember the waist to hip ratio? I can tell you that in the morning, my wife tells me every single morning, your waist is gone. Like you have nothing there. It's like literally like this, right? And that's a bad thing. You need to be able to have a waist, and that waist to hip ratio for men and women have to be there. And it's bad to have fat above the waistline. Is this polygenic? A big question. Again, this is the overarching question for today's lecture. Is there actually a genetic cause? And can we, as human biologists, using molecular techniques, possibly overcome this obesity and or metabolic syndrome epidemic? Issues with insulin, again, it's a syndrome. So insulin issues, hyperglycemia, you have dysregulated glucose levels in your blood. It's too high, in other words. And this fat deposition. So if we take a look here on the left, you'll see that in yellow, this is where an individual has fat. Overall, their waist circumference is the same. They might have the same waist circumference. But these two individuals are dramatically different. They might not look like they're overweight. They might not look like they have metabolic syndrome. They have exactly the same waistline, but the person on the left is actually better off than the person on the right, because the way that the person on the left has deposited their fat is around the outside portion of the abdomen. And this individual here on the right in yellow, this is where their fat is. It is surrounding the organs. And we call this visceral fat because it surrounds the viscera, or the internal organs in the abdominal cavity. And that's bad. Can you detect that? Not by eye, not by doing a hip to waist ratio or anything else. You can't really determine that easily. So if I'm standing up here right now and you're saying, well, you know, you don't look very fat. You don't look like you have problems with metabolic syndrome. How do you know? You can't, because you don't have an MRI scan of my internal organs. And this is one of the things that you have to do. An MRI scan is the definitive diagnosis of having the fat deposition that leads to metabolic syndrome. Now, the two MRI scans that you see here are actually at the top of the same individual. And a magnetic resonance image, whether it's used in sports physiology or sports anatomy, is the same as you would use here in metabolic syndrome. You can actually set the weighting to see the levels of fat. And here is an individual where we are looking at where their fat is deposited. And their fat mass overall is 19.8 kilograms, and I'll get to how they measure the fat mass in a moment. And you can see where it's deposited. It's around or packing the internal organs. This is sort of the outside of the body. They're lying down. You've cut in cross section. Here's their spinal cord, and you can see that this is where their fat is. This individual has the same circumference. If you look here, their circumference on the bottom is more or less the same as the individual here at the top. Their fat mass, and the way that we measure their fat, is 19.8 kilograms, identical. However, if we take a look at their visceral fat adiposity, overall, theirs is much, much lower. They have less fat packing their internal organs. The individual at the bottom has less of that white fat surrounding the internal organs. He is less at risk of developing metabolic syndrome for precisely the reasons that I mentioned to you earlier. So could we tell just on visual inspection? No. Could we tell by using the waist to hip ratio? No. Could we have told by using the BMI? We couldn't. And it's really this type of test that you have to be able to do. So yes, we can still try to do all of these other things, but the MRI is really one of the definitive diagnoses. So again, for men, it's a little different. We look at the waist circumference and the waist to hip ratio that we talked about in the last slide, or the last lecture, and because it's a syndrome, we have dysregulation of triglycerides, we have dysregulation and lowering of the good cholesterol or HDL, your blood pressure is going up, the cardiometabolic effects that we talked about, and dysregulated glucose. It's high. Even when you're not eating, the glucose is not being deposited appropriately, and as a result, fasting glucose levels are high in men as well as in women. Just out of curiosity, do you think you have to memorize these numbers? No? Yes? Thumbs up, Facebook like if yes you do. No, you don't. Don't have to memorize the numbers, but I'd like you to know how we actually measure this. Now, I'm hoping that some of you will take some of this away because some of your parents might be in that range where you have issues with metabolic syndrome. So fat content, as I mentioned to you before, is not the same as a body mass index or BMI. Do you know what your fat content is? Anyone know? Just out of curiosity, you had to have gone in for a test. You can't really just go in and eyeball it and say, yes, you have like 15% or 50% fat. You actually have to get tested for it. If you have 15% of your total body mass being fat, it's actually considered you're very, very good. You're almost an elite athlete. Whereas a normal individual, many of you will be in the range somewhere between 15 to 20% of your body weight is due to fat. You need fat, by the way. You can't go through life without having any fat. And if you have 26% or over as your fat content, then you are considered to be obese. Now, again, let me ask you a question. Do you need to memorize these numbers? Yes, you do. And these are numbers that I'd like you to make sure that you are familiar with and know fairly well. And there are some ways that we can measure this fat content. And sorry, I'm a really big old school Chicago Bulls fan. Not so big into Rose right now, so I'll put up a picture of Michael Jordan. And at the time, he was supposed to have like the best the lowest fat content. And you can see he's like very sinewy, full of muscles, jumps a little bit higher than I do. And you can tell that, you know, he's a really fit individual, and his fat levels were considered to be extraordinary at about 7% of his body mass being fat. Now, how do you measure fat? There are lots of ways. You can do this really fast, easy method known as a skin fold measurement. Some of you might have that done at the GP that you visit. Some of you might have had this done in some of the physiology or human biolabs where you can actually use these types of calipers to measure the fat content. And you can actually use 3 to 7 different standardized zones. It's not everywhere. You don't just put it on your earlobe, for example, and say, yes, you have a lot of fat. You actually have certain regions around the waist and in other regions where this particular type of reading is done. You can also sit in a water bath and do hydrodensitometry, where you can measure the amount of water that's displaced and you can calculate your fat that way. It requires very specific equipment. You cannot do this in a doctor's office, it's really accurate, unlike the skin fold measurement, which tends to be inaccurate and won't tell you about the visceral fat at all, as you can imagine, just the subcutaneous fat that you're collecting around your waist. And then there's this other type of scan, which is known as a DEXA scan, also requiring specialized equipment. It's very rapid. There's some advantages to doing it, and you can see what's going on here. So both of these individuals have a BMI of 32-ish, 31.7. This individual is different here on the left than the individual here on the right. A totally different individual. Body mass index is relatively the same. This is not an MRI. This is a dual X-ray absorption scan that used to be done to measure bone density. But when they were measuring bone density, they also realized that soft tissue also lights up in a different color. So you can actually measure fat using this dual X-ray absorption. So you shoot a tissue with X-rays twice, and you see how long it takes for the second X-ray to come back. And it tells you about the density of the tissue that you're looking at, and it generates a picture that looks a lot like this. And you can see that this individual here actually has much, much more fat. Even though the BMI is the same, the fat content actually is higher in this individual than the individual here on the right. So this DEXA scanning gives us another way to look at fat content. Doesn't measure visceral fat per se. It can tell you about visceral fat, but it's not looking only at visceral fat. It's just fat content overall in the body. Do you have any questions about this before I go on to sort of the next section? No? So I want you to start to think about this. There's an issue. We are collecting fat, and fat is a collection of adipocytes, as I mentioned to you earlier. These adipocytes have a genetic program that allows them to convert excess glucose into fat and store it in those in the lumen. And why is this a problem? This is a problem because one of the things that happens in metabolic syndrome is what is known as meta-inflammation. So those adipocytes that you are collecting, and particularly the adipocytes that you're collecting around the internal organs, are the ones that are going to be secreting all of these inflammatory factors. So why is that a problem for you? Is it a problem for you? Do you want to have like low-grade inflammation all the time? Sounds like a good idea, right? To have like low-grade inflammation all the time. So one of the big issues for me is I have low-grade inflammation all the time. And this becomes an issue, for example, where I have meta-inflammation, low-grade. So nothing over the top, but I have like really high cytokine levels. I have a number of other sort of things that indicate that I have low-grade inflammation. But it becomes an issue because those cytokines affect my body in a lot of ways. So when I exercise now, and I try, right? So this is where the positive cycle thing comes in. So I know I should be losing weight. I know I should no longer be as overweight as I am. And so I want to go out and exercise. But guess what happens? The first time I go out and exercise, those adipocytes are actually releasing more of these cytokines. So my hands balloon up like you wouldn't believe. It looks like I'm wearing these. If I were wearing my wedding ring and I was exercising, I'd have a really hard time taking it off. It looked like little sausage links on my fingers because I have that inflammation. And so do you think I want to exercise? I don't. And it's really something that bothers me a lot. So I need to get over that sort of psychological hump about getting past this inflammatory response. We don't understand the mechanism completely. We do know, however, that when your adipocytes change, they change molecularly and they change the immune system that is surrounding it. So if you take a look here on the left, so this is a slightly different type of diagram than I showed you earlier for the adipocytes. So each one of these represents one adipocyte. Here is that blood vessel or capillary that I showed you earlier in that other yellow and red diagram. And you can see that normally your fat, the adipose tissue, is actually a collection of tissues. It's blood vessels, it's fat cells, it's also immune cells that sit in amongst them. And so when you have normal metabolic function, you have these normal adipocytes, your inflammation levels are relatively low, you have great metabolic control. In other words, when you eat something that has glucose, your body drops your blood glucose levels really quickly afterwards. And the immune cells that are normally associated with it are things like CD4 positive T cells. Everything is working well, and you have these M2 types of macrophages. These the adipocytes, by the way, the ones that you see here, are actually helping you not to have inflammation. They're controlling the inflammatory response if you are a normal individual with normal metabolic function. These adipocytes are actually secreting anti-inflammatory cytokines, which we call adipokines. They are secreting things like adiponectin, and they are secreting things like SFRP5. And that's controlling your inflammation rates. That's where I want to be at. Now, at some point, I'm sort of just beyond this point. So I'm not obese, but I also know that I don't have good control over a lot of my pro-inflammatory factors. When you start gaining weight and you get visceral adipocyte accumulation, there are a couple of things that you see right away. These adipocytes that were here, you have to imagine now you've just accumulated more of the triglycerides, etc. They're getting bigger. Okay, and each one of these is now much bigger, and the types of cells that are associated with these are different now as well. We have these CD8 positive T cells. The CD4 positive ones are not as common anymore. These are much more common types. The M2 macrophage that we started out with has now been replaced by an M1 macrophage. Why is that all important? The factors that are being secreted by the M2, M1 macrophages are dramatically different. And we'll get back into that when we look at some of the controls for obesity, including things like exercise. Can you reverse the process? Yes. And how can you reverse the process through exercise? We'll talk about the conversion of M1 back into M2, or the replacement of M1 back into M2. But if it continues, there's a point of no return. At some point, it's too late to be able to go back. If you have full metabolic dysfunction for a very long period of time, or a significant period of time, you'll actually have changed your adipose tissue to an extent where it's almost impossible to work your way back. And at this stage, you're kind of at the middle. You're producing anti-inflammatory a little bit and more of these pro-inflammatory, and then you come all the way over here. And now, instead of producing all of these good factors that they did on the left side, they will now start producing all these bad factors, pro-inflammatory cytokines, things that make you want to have an inflammatory type of response. The adipocytes themselves, because now they're getting big, now they're getting almost too big, they actually start to die off through necrosis. The blood vessels are no longer in contact with all of the different types of adipocytes. So we know that there are molecular consequences, physiological consequences, potentially behavioral consequences, and as human biology students, you need to understand all of those different aspects. Again, let me just double check in with all of you right now. Is this a diagram that you need to make sure you know for your midterm? Of course. I love that answer. Of course. Yes, you do. So these adipocytes are very, very strange. So we know that in my era, when I was sitting, well, we didn't have earth sciences. The building didn't exist when I was an undergrad here at U of T. But when we were sitting in lectures over in MSB as undergrads in physiology or in biochemistry or pharmacology, we were taught that adipocytes, the only role that they had was that they were there to store fat, and that's it. We now know that those adipocytes secrete a number of different factors directly and or indirectly. They have many, many different functions. They can act in some ways like stem cells. We can convert adipocytes into stem cell-like cells. And we know that they have endocrine functions. In other words, all of these things that you see with arrows coming out are both acting on adipocytes as well as being secreted by adipocytes when the arrow is going out the other way. We know, for example, that many of the important factors that are secreted by adipocytes are factors that will control our hunger, the way that you want to be able to eat. And I told you at the beginning, some of the problems that we have with obesity is really at the top. How do we control hunger? You get hungry where you have a physiological craving for food that is driven by the adipocytes and their release of leptin. And we're going to talk about this factor. So all of these different factors that you see here are released by these adipocytes. We're not going to go through all of them. We'll go through the ones that are outlined for you in red. Does that mean that you have to know all of the ones that are here in black? No, you do not. And so the only ones that you should be worried about are the ones that we're going to go into in more detail, like resistin, TNF alpha as a cytokine, adiponectin, as well as leptin, because this might control our metabolic status. So this visceral fat, especially the ones packing the organs, the ones that I showed you on the MRI, the ones that I showed you are really bad for you in terms of metabolic syndrome, they're the ones that have converted over. They're the ones that are now on the right side of the diagram that I showed you earlier, and these are the ones that are now secreting things like TNF alpha, things like interleukin-1 as well as interleukin-6, which were not on that previous diagram. We know that when we start talking about animal models, including mouse models, which we'll get into in some more detail on Monday, that these particular cytokines, if we overexpress TNF alpha or we inject in TNF alpha under the right conditions, or interleukin-1 or interleukin-6 under the right conditions, can produce insulin resistance, which is one of those sequelae of events that occurs in metabolic syndrome. So there's some suggestion that, yes, it's the adipocytes, the changes, the genetic programming in the adipocytes, the release of these factors from those adipocytes that might be really important in this metabolic status response. So I have a question for you here. And do you guys like to gamble or not to gamble? Yes? Good? Okay. So just looking at this here, in any of your biochemistry or other classes, what is this pathway, or what does it start with, and what are we looking at? Can anyone tell me? If you can, without Googling it, I will make it worth your while on your midterm. You can't answer. Thanks, Maj. Anyways. Yes. Well, it is the JAK-STAT pathway. Great. How about upstream? What are we actually looking at? So what activates the JAK-STAT pathway? Any ideas? Yes. How many of you think that this is a leptin signaling pathway that involves JAK-STAT? I love the U of T confidence. Yes, it's like watching a bunch of groundhogs, you know, kind of up and down. This is indeed the leptin signaling pathway that we will be talking about in more detail. We need to understand the upstream effects. Hunger, how do we control hunger? It's through this leptin pathway. We know from mice that we'll talk about in the next lecture in mice models that this pathway is really important in the hypothalamus, and that without this proper control, we have conditions that lead directly to obesity. So we'll talk more about this. You don't need to memorize this now. It will be back in the next class as part of the different animal models. And I'll make it worth your while. Right before your midterm, I will give you one of the questions for your midterm, the multiple choice test question, right before you actually write it, and it will be identical to the question that you get on your midterm itself. So let's go through our 3x3. So I don't want to talk about the ones that you found most interesting, but I do want to know which ones you thought were going to be more challenging for you if you are studying and not hanging out at McDonald's this weekend. Anyone want to share? Or how about we do this? Which pages do you think will be on your midterm for sure? Yes? So the diagram related to health status? The adipocytes, for sure, you will get that. And one of the reasons why I ask you to make sure that you circle 3 slides, at the minimum of 3 slides, is that for each of the lectures that I'm giving you, you should expect about 3 to 5 multiple choice test questions. And so if you're doing that already, you're getting ahead of the game a little bit, and I will try to make it consistent between the lectures in terms of the numbers of multiple choice test questions. I am going to be posting things throughout the weekend on Blackboard. And I will be posting things related to your midterm, how you should be studying, some extra information, etc. I know that you have other courses as well, so I don't want to be over taxing you. And just one other thing before you all take off is, if I can get it to work, hopefully. Do you guys know how to get the little pointer thingy back? Any of you? The major message that I'm trying to send you is, I want you to study, but I don't want you to be killing yourself studying. Make sure you do get some sleep. And for those of you who hung around, you can take this for whatever it means, but you should maybe make sure that you go through and study up on these particular aspects of adipocytes as well as meta-inflammation. It will be. I'm coming back to it. No, I think I was mentioning that if someone answered the question, I would make sure that before the test, that you would get the multiple choice test question. I think. Are we stopping this? Do you know how to stop it?
No, I'm just Wait. Hey, do you know how to stop it? How are you supposed to stop it? Oh wait, there. You guys gotta stop sharing. Oh wait. Oh yeah, stop it. Yeah.